Welcome to lesson 3.4 Quadratic Relations in Factored Form. So far, we've taken a look at quadratic relations in standard form, and we've looked at quadratic relations in vertex form. So now we're going to look at quadratic relations in factored form. And we've got an example of it right here. The only difference is we're going to use R and S instead of P and Q. So it'll be y equals A times x minus R times x minus S, where R and S are going to be our x-intercepts. Once again, if A is positive, our parabola opens upwards and we have a minimum point at our vertex. And if A is negative, it opens downwards and we have a maximum point at our vertex. So let's explore this. Our goals determine x and y intercepts for quadratic relations in factored form. So recall the distributive law. Um, this is an example of factored form. What we're going to do here is we're going to expand this and simplify the expression. So if we were to do that, first thing we have to remember is how to multiply two binomials. And when we multiply two binomials, and this here, x plus 4 is a binomial, two terms within the brackets, and x minus 5 is also a binomial. So we're going to multiply those together, and we have to multiply every term by the other one. So what we're going to do to make sure that happens is follow FOIL. And FOIL tells us that we have to multiply the first numbers or variables in our brackets, and then we're going to do our two outside terms. Then we're going to come to our inside terms, and finally our last terms. So that's FOIL. First outside, inside last. So let's show you an example here. The first thing I'm going to do is I'm going to multiply 3 by x plus 4. And because of the distributive property tells us that that's okay to do. And you can check it if you want. You could also multiply your two binomials together first and then multiply by 3. We're going to get the same answer regardless. So I'm going to do 3 times x, which will give me 3x, and then 3 times 4, which is going to give me plus 12. So my new binomial is 3x plus 12, and we're going to multiply that by our other binomial, x minus 5. So here we're going to use FOIL. 3x times x is going to give us 3x squared. 3x times minus 5 will give us minus 15x. 12 times x is going to give us 12x. And finally, 12 times negative 5 is going to give us negative 60. Last step here is we're going to collect our like terms, which in this case are our two x terms. So, minus 15, whoops, minus 15 plus 12x is going to equal minus 3x. So what we're left with is 3x squared minus 3x minus 60. And if you notice, this is an ax squared plus bx plus c format, or our standard format. So we can easily switch between our factored form and standard form for quadratic relations. If we have a factored form, we just expand and simplify it, and it becomes standard form. And if we have standard form, we'll factor it in order to bring it down to factored form. Good news is we're not going to do that in this lesson. We're just going to explore the factored form. So if we consider the quadratic relation, y equals 2 times x minus 1 times x minus 5, and we want to make sure that if we expand this and change it to standard form, that it really is the same equation, we can do that. And that's what we're going to do. We're just going to verify. So if we were to expand this, what we'd end up with is 2x squared minus 12x plus 10. And then we can use a table of values to verify that when we sub the same x point into either equation, we're going to get the same y. So we can just see from our table of values, we use numbers 0 through 4. In this one, we're in factored form, and over here, we're in standard form. And we can verify that our answers are correct. 10, 0, minus 6, minus 8, minus 6. And we'll notice that matches up perfectly with our standard form. 10, 0, minus 6, minus 8, minus 6. So, really, really good news there. And we can actually learn a little bit more from this table of values, too. So, one of the things that we can notice is our x intercepts. So, our x intercepts are when y equals 0, and that's just the point where our parabola is going to cross our x axis. So, we can see over here y equals 0, x is 1, and if we were to expand this one more and enter 5 into this, we'd find out that once again, we've got y equals 0 when x is 5. And that's going to become important. So, a quadratic relation, written as the product of two binomials, is said to be in factored forms. So, as I kind of showed you there, in the table of values for our factored form, we found out that one of the x-intercepts was when x was equal to 1. And these are also known, our x-intercepts are also known as zeros. So here we'll see our first x-intercept is 1, 0. And if we were to substitute in 5 as well into that equation, we'd end up with our other x-intercept at 5, 0. And you'll notice here that the signs of the factors appear to be the opposite of what's in our equation. And this should make some sense when we see here, um, if we sub 1 into our first binomial, 1 minus 1 is going to be 0. And since everything is multiplied together, that means the entire equation goes to 0. So y equals 0. So our goal is to find numbers that are going to make each of these binomials equal to 0. Simplest way to do that is take a look at the number in the bracket, and your variable will be that number with the opposite sign. So here we've got minus 1. What x value can make this 0? Positive 1. 1 minus 1 will be 0. Same thing here. We've got minus 5. So if we want to make that 0, we can do x equals 5, and that'll make it 0. We could even look at it in terms of just taking one of our binomials and just doing the following here. X equals, whoops, I got my caps lock on. X, x minus 1. That's one of our binomials. And if we set it to 0, then we can just do some base algebra to figure that out. And what we're going to get is x equals minus 1 goes to the other side, becomes positive 1. Do that for the other one as well. Well, let's just do that. We've got x minus 5. We want to find out what the x-intercept is, or what's going to make this go to 0. We'll just set it to 0. And then when we do that, well, the same thing will happen here. Let's just scroll down so you can see it. X, well, minus 5 goes to the other side, becomes a positive. X equals 5. So that's really, really kind of neat to see. The other thing to notice here is that our y-intercept is at 0, 10. So when x is 0, what does y equal? If we go up to our table of values, x is 0, y is 10. That's our y-intercept. The other way we could have found that is to take all of our constants and we could have taken our constants here, but just switch the signs that are in the brackets. We'll actually come up with a formula for this so it won't be confusing. It's going to be 2 times 1 times 5. So we multiply all our numbers together and we're going to get 10. And that is our y-intercept. There's going to be another way to find that. I'll teach it to you very shortly here. So factored form of a quadratic. Well, a quadratic relation in factored form, y equals a times x minus r times x minus s, has x-intercepts of r and s. And as before, if it opens upwards, that means that a is positive. If it opens downwards, a is negative. Its y-intercepts are just going to be a times r times s. So remember, because our formula in factored form has negatives, it's a times x minus r times x minus s. R and s, when they come out, we just have to switch the sign from whatever in the brackets. So we're going to do an example here. We're going to use this. We're going to state the intercepts for the relation y equals 2 times x minus 3 times x minus 5. Let's pull out the drawing tool here. Let's use green. And if I want to find my x-intercepts, well, my x-intercepts are also known as r and s. That's an s, not a 5. And in order to find those, all we do is we look at what is in our brackets. R is going to be the opposite of this number, so this is minus 3, so R is going to be, let's just dull down the thickness there. Oh, much better. R is going to be 3, and S, we see minus 5 here. Just remember, switch the sign. So S is going to be positive 5. Really quickly, I'm just going to fix up my S so people don't think it's a 5. So S equals 5. Now, in terms of my y-intercept, well, all I do to find my y-intercept is I'm going to do, remember our little formula there? It's going to be A times R times S. So what's A? Well, A is 2. R is 3. So we're going to put that in brackets here. And then S is 5. So that's going to go in brackets too. My brackets need some work, that's for sure. And now all I have to do is 2 times 3 times 5. Well, 2 times 3 is 6. 6 times 5 is going to give us 30. So, once again, our x-intercepts are going to be at points 3, 0 and 5, 0. And our y-intercept is going to be at 0, 30. So we're going to do this second one. I'm actually going to try and make it look a little neater. So I'm going to use my computer here. State the intercepts for relation y equals minus 3x times x plus 7. Well, this is an interesting one. We can look here and we can see that we've got minus 3x times x plus 7. Huh, that's interesting. Remember, we're trying to make this entire equation go to 0, so what values will make it go to 0? Well, I could rewrite this another way. I'm going to get rid of the drawing tool just so it makes it a little bit more clear here. Minus 3, in brackets, I'm going to put x, and then I'm going to put x plus 7. Same thing here. So our R value is actually 0. That's what's happened here. we don't have an r value, it's 0. So what's going to make that go to 0? Well, if x is 0. So our r value is going to be 0. Our s value is going to be minus 7. Remember, always use the opposite sign from what's in there. So my x intercepts are at the point 0, comma 0 and minus 7, comma 0. Our y-intercepts, let's actually just come down one more here. Y-intercept is going to be at a times r, whoops, times s. So our y-intercept is equal to a is 3, minus 3, r is 0, what's s? Minus 7. What's going to happen here? Well, minus 3 times 0 is 0. 0 times minus 7, also 0. So our y-intercept is going to be at our point 0, 0. All right. I'm going to stop the video here, and we're going to have part 2 as well. I'm just trying to keep the videos a little shorter. So hope you enjoyed part 1. Join back in for lesson 3.4, part 2.